Hey, good afternoon, folks. Today I'm going to talk. Sorry.
No, go, please.
Okay,
Welcome.
sorry. I heard a noise and I thought maybe I'm too early. But hey, folks, again, it's me. And today I'm going to talk about Java security practices because think about it. What did you do in school? You probably learned, if you did computer science or something similar, you probably learned how to program and how to create stuff, but not so much how to create secure stuff. Did you? Well, think about it. Let's look at this slide first. This is a picture of King's Cross Station in London. And of course, it's modeled after the famous Harry Potter movies. And you know, in the movie that Harry Potter goes into the wall and ends up in platform 9 3/4. But think about it. Normally, there is platform 9 and platform 10. And only if you know where to go and that you have to run through the wall with your cart at the right speed at the right time, you are able to get inside platform 9 3/4. It is basically a similar way with software and with the application that you create. From the outside, an application looks tough, looks good. We test on its functionality and we see if things are working or not. But if you do things in a not so good manner, then you just have to know where to push and pinch and get the right amount of force into that program at the right spot to get behind that wall and into stuff that you actually do not want to show to other people. Am I right? So today I'm going to tell you some common mistakes and how to prevent it, and more importantly, why. But first, this is me. I'm Brian Vermeer. I'm a developer advocate for Snyk. We do a lot of security stuff. We build security tooling mostly and do some research on that, etc., etc. We have a very, very nice blog on Java security, so read it. I'm a Java champion, do a bunch of stuff in the community, like for the Virtual Jug and the Dutch Java User Group, the NL Jug, and some other stuff. But the main question we are having today is, who is responsible for security? Well, we asked this to a lot of people in our yearly survey we call the State of Open Source Security. And it turns out that it's about this. Like, if you look at software security, so application security, people say that it is a shared responsibility between security team, developers, operations, and maybe even other people. But also people believe that 81% at least believes that developers need to take their fair share. So we as developers, we create stuff. We know what code we're using, what dependencies we're using, how we build up the code, and how we solve the problem in a particular way. We need to be aware that this way is not only good, like in it's scalable and maintainable, but also that it is safe. So yes, we need to take care about security. So let me get into the first one, SQL injection. And SQL injection is the all old one, and hopefully it will be soon there. But if we look at the OWASP top 10 vulnerability, SQL injection is still somewhere at the top. And that is for a reason, because it still happens. Let me give you some brief explanation about SQL injection is, how it works, and how we can prevent it. And I do that by using a demo application. And of course, I need to go to the correct screen, and I think this one is the correct screen. Yes, it is. Let me just run this application. It does not even matter if you cannot see the code yet. That will happen in a few seconds. Let me spin this one up. And yes, it works. Amazing. So let me spin up a browser. A browser. Ta-da! So localhost 8080 is my demo application, and my demo application shows you, like, I have a bunch of users in this application. You can see I have a user. Let me enlarge this so you can actually look at it. And every user has a nickname like Batman, and a first name, a last name, and a comment, and etc., etc. We have all of them. What we can do in this box, we can search. So we can search for usernames, as it says, like Spider, and I can use a % to use it as a wildcard, which cool, works. But what I did as well over here, I didn't do my SQL collection, or I didn't do my SQL query I didn't do it in the right way. So I can do also things like, if I do things like this, and I say, or first name is Bruce with an extra quote, then I'm not only searching at the username, I now also am able to search at the first name. And this is not really important, but what do you think about this one? What I do over here is, with this sign, with this semicolon, I quit my first query, which is probably a select query, and then I just start a new one by update users, set first name to hello Istanbul. And I probably misspelled it, but I'm not. So it will not give me any results. But if I look back over here, then you see all the first names are hello Istanbul. You got me? This is wrong because I implemented my SQL towards my database in a, well, vulnerable manner. Let's get into the code and I will enlarge it, trust me. But I first have to look at the repository, the search repository. And you see it's already a bit larger than you expected. What you can see is that this is my find user by username thingy. And what I do is I have my SQL query over here, but I naively just take the parameter and make this part of the SQL query by concatenating the strings. And what happens is, if I concatenate a string in such a way that it closes this quote, and for instance do what I just did, like over here, do the semicolon, and I can just start a new query. And we can solve this easily. Of course, in frameworks like Spring nowadays, we have stuff that can help you with it, like Spring Data that does a bunch of stuff for you. But it's good to know like what you're actually doing. So let me change this one for you. First of all, what I'm going to do is I'm not going to concatenate stuff. I'm just doing a question mark. And I'm not using a normal statement. I am using a prepared statement. So let me just fix this one. Instead of a create, I will do a prepared statement based on the query I just created. That is cool. All right, I probably need to import this one. No. Oh, prepared statement doesn't exist. Of course not, because it needs to be like this. Okay, what I do next is, instead of, again, I need to insert the parameter still. By doing this and giving the parameter over here, statement, dot set string, of course, and give me the parameter. Okay, let me just explain you what I do. It is not just a weird way of doing things, but a prepared statement is a actual different thing than a normal statement. What I do with a prepared statement, I give it the query with a question mark, with a wildcard, with a variable. I already passed this query to my database. So actually the sanitization takes part on the database. I send this to my DBMS, and my DBMS is already able to create the execution plan. Got me so far? With the query, the database management systems try to get an execution plan. And in a second step, I provide the parameter. Because I provide the parameter in the second step where the execution plan is already created, it is impossible to do SQL injection like this. So instead of doing sanitization in my application, I leave it over to the part that is way smarter than that, which is basically the database. So if I do this and I just insert the parameter like that, and I restart it, you will see that SQL injection is not possible anymore. From a perspective of functionality, it still works the same. I can still search and it still works, but now I'm not able to enter into data that I'm not able to see or able to change. So let's get back to the browser. Let's restart this search, and we already see that it reset it. And let me just do that again. Well, let's say first name is evil, because I am evil at this point. If I submit, nothing comes back, and if I search again, you will see that the first name is there. Because of the prepared statement, it is not possible anymore to do a SQL injection because the plan is already created on the database side. Therefore, prepared statements in basically any language are more or less the way to solve SQL injection. And it's probably also the way how a lot of libraries that you can use take care of that. Cool. That was the first one. So that one went quick, but I only have 45 minutes, so we need to continue with a bunch more. Where did I leave my presentation? Cool. Next one, sensitive data. We need to take care of sensitive data, right? We need to make sure that people only see the data that they need to see. Basically, what we want to do is practice the least privilege principle, or the principle of least privilege, or whatever you need it, or whatever you may call it. The point is, you only need to have access to the data that you need, not more, not less. So if I have access to more data that I actually not use or not need, I might see things that are not for my eyes, or I can do, well, harm with it. Let me give you an example. Say I have a user, and you see in my example, I use Lombok just for the sake of making it shorter. You see this user has an ID, first name, last name, and an address. But say this is my endpoint, just a gap mapping for the users, and I just get the user from a database and push it over to there. Basic prototyping. But what happens is that everything that is in my domain entity user will be published as JSON. I mean, I basically return all users, correct? So my JSON will look like this. I have an ID 1, I have the first name, the last name, and the address. But think about it. In my application, I maybe only need to display the first and the last name. If that is the case, ID is still important and address is still important, but you do not want to display that maybe in the JSON output for a particular front end. So these things can do harm because, first of all, hey, an ID can point me to something else. Of course, hopefully not only an ID, but if the ID combined with other data can help me to insert maybe new comments for that user, that is not something that might be useful to me. And this is the pure REST call, right? I'm not talking about interfaces, but I'm calling about the REST call and the JSON that comes back. But also address. In Europe, we have GDPR, and we have different laws in the United States, in California, whatever. If you combine in the largest part of Europe, if you combine a first name, last name, and an address, you have a data lake, because now you combine personal information with identifiable information. And that is not something that you want. So we need to take care of these things. And for instance, if I was using Lombok, right? And I returned all users. And there's a simple explanation to do this because in a Spring Boot application, I probably use my JSON parser, which by default is JSON. It has an annotation for me. The JSON part has an annotation for me. It's nothing to do with Lombok, but with JSON, I can do basically this. By just inserting that @JSON_ignore, I will make sure that if I just remove the user as a entity, the ID and the address will not be part of the output. So if I just put the annotation of @JSON_ignore, my output will be like this, just the first and the last name. This is just a very, very silly example, but take a good look at how your application responds to this. And if you're not pushing complete POJOs to your endpoints, so that they are visible in your REST call. If you do that, you might want to sanitize that, because even though your front end is not using them, people might be able with things like Postman or Insomnia or what kind of browser or kind of tooling to do the raw JSON or raw call to your endpoint and get the raw JSON out. And in many cases, if you combine different data like the ID with something else, and you provide that as input to another endpoint, it might do you harm. It actually happened to me once, like years and years and years ago, which made me do this topic. There's another thing, and I already called you out on Lombok, right? All of the things what I want to do, and I'm doing it right here as well in my application. Oh, I shouldn't be doing that. Play slideshow in window. This always happens to me, but don't worry, we're there. If you look at my application I just showed you earlier, and this one, it's over here. If I am restarting this, you will see that I'm outputting every user that I insert, because I do that at startup, and it is in my log file. And I know it's small, but I will be happy to enlarge this for you by doing this. You see that every user, I just printed with a toString. And you see that the password, of course, you shouldn't be storing a password as a plain text, but this is, of course, for demo purposes. You see that the password is printed over here. And so can be the same thing with IDs and that kind of stuff. You also don't want this stuff in your log files, or as minimal as possible, because if your log files are leaking, then you have the same problem. Or you have to think about who has actually access to that log file. And does that person need, for instance, a social security number of a certain person? Well, there's an easy way out for this, and I can show you already. Like, because I said I am using Lombok, I can overwrite the toString. That is easy, but I'm lazy. I'm sorry, I'm just lazy. So instead of overriding the toString completely and only saying first name, last name, and user, I am just saying over here, and I'm excluding this from the toString. By doing this annotation, and you will see when restarting this, it will not end up in my log when I print out this user, when I print out this POJO. So don't only think about what's actually visible to the user, what's externally leaking, but also what is internally leaking, because also operators do not need to know everything. And you see over here, also my log is now sanitized, that it's not visible here anymore. Got me? All right, so think about sensitive data and how you do the data architecture in that case, so that you're not exposing too much. That is basically the reason why. Yep, explaining that here, toString.exclude. And I can do both, like JSON ignorer and the toString.exclude. Next one, dependencies. Because a lot of stuff that we hold, well, we use a lot of dependencies, right? I mean, can you imagine the last time you wrote a full-blown enterprise level application without any dependencies? And I'm not calculating in your test dependencies like JUnit 5 or something, but you probably use things like Spring or Quarkus or whatever framework, maybe even Apache Struts or something like that. It doesn't really matter, but because if this is the binary that you put into production, a lot of that binary that you put into production, like jar or that var, is not your code. Some of it is, but some of it's not. And it's probably, this is the ratio. This is the code you wrote, and that is the code that you put into production. Because if I, for instance, like the demo application is a Spring Boot-based application, and it brings already in a lot of packages, and all these packages are there and available in my class path. However, for that part of your own code, we probably have things in place like code reviews and pair programming to make sure that that code is okay. And you're now here to listen to me rambling about how to do proper SQL, make sure that you're not doing SQL injection, the kind of stuff, and that you can recognize it later. So we take good pride of that code. But the larger one, the frameworks, in many cases, we just basically pump it in because we saw it on Stack Overflow or on some kind of blog, and it works and it's there and we never update it again, right? Well, I have a Spring Serverless example over here, although a snippet, and that snippet was 222 lines of code. Of course, again, it was bad code. I wrote it, a lot of duplication, but it was a demo. It had 5 dependencies, 5 direct dependencies, but we know that dependencies, having dependencies, and etc. It goes several layers deep. It comes back to 54 dependencies in total. So these are the amount of jars that I basically put into my system, into my executable Spring Boot application or something, whatever you're using. Point is, 222 lines of code with 54 dependencies ends up in about 400,000 lines of code. Well, 450, almost 500,000 lines of code. So you see that less than 1% in this case was the code I wrote. The rest, I blindly imported from somebody else. I borrowed it, and that's for a good reason. But remember, a lot of these packages are open source, are used, and it's good, but checkers are targeting open source, right? If there is one vulnerability in a package that is well used, well known, and heavily used in the ecosystem, and I found an issue in there, that there can be a potentially big pool of victims. If 100,000 people are using 100,000 applications or 100 million applications are using a typical package, and I found a vulnerability in it, I'm just trying to use it, and I'm just pointing at these things and trying it out. And I will show you an application that has this issue, and it's not so much in the custom code. It is in the how do you call it? Dependencies, and it's this application. And again, I will show you. It's a Spring Boot application with Spring Data, and it's a somewhat older version. And this application is not really important. Oh, wait. I need to make sure that the other application is shut down, or else we have a port conflict, and that is not something that we want. Cool. So this is a grocery list. It has beans for 50 cents and milk for $1.09, like nothing really special. Also, my domain entity, it is an item, and it's not really special at all. It is an ID, a name, and a cost. The ID is generated, the name and the cost are there by the constructor, and it has some getters and setters. The interesting part is the item repository, because in this case, I am using Spring Data. And Spring Data, of course, if I extend the CRUD repository, I don't have to do all that SQL stuff I showed you in the first place. Cool, I already got rid of that. Although, hopefully this works well. Just be sure that if you insert queries yourself, that you're still aware of what SQL injection is. However, by just annotating this, by just saying the find by name in this interface, I do not have to create the implementation myself. No, because of Spring, it generates the implementation for me. So find by name with a name will give me the reasonable item with that name. Cool. So CRUD functionality is there, but I am also using Spring Data REST. And with this annotation, with the repository REST resource, add repository REST resource, I transform my CRUD repository into a REST endpoint, or into REST endpoints, plural, which is cool because now I don't need to do anything. I already have a prototype. I just put it there, and my front-end folks can just talk against it. Pretty cool, right? So let's start this one up. And again, pray to the demo gods that this one works. I believe so. I tested it an hour ago, but you never know, right? Boom, it's there. Cool. So localhost 8080 will now get me to my hell browser, and that was the thing I showed you with the hell browser is just another dependency that shows me what I can do with certain endpoint. For instance, /item/1. That gives me the first item in my grocery list. Cool. But I can also do things like search, find by search, and do the find by name, that CRUD endpoint, and give it beer. So now I find beer, and cool. So this is the normal functional way, but there's something going on. Now let me show you that in a terminal. So make sure that it's large enough. Yes, cool. So demo sneak. I prepare this. So let me show you a thing that I can do over here by giving you the Spring REST exploit. Let me just show you the header first. And that is a JSON header. All right. Let me give it like this. What I can do a curl request to this endpoint, and this is a curl patch request. And with a patch request, I'm allowed to give it a JSON body. But particularly for this version at Spring, I am allowed to, for some reason, with a curl patch request, I can utilize SPEL, the Spring Expression Language. And with SPEL, Spring Expression Language, word stands for, I can interfere, or I can call certain things like the getters and setters on a object that is there in memory, or I can even possibly create new objects. And what I do over here is, what I say over here is, hey, I'm getting the runtime and I'm feeding it an arbitrary command. So what I try to do here with these SPL, I try to get the runtime and feed it an arbitrary command. So that means spinning up another thread and making sure that, well, basically a Linux command is run. Let me see how that looks like in a real exploit. This was just a header. And let's do the, not to use, say the pass WD. So by doing this, you see I'm doing a curl patch request over here, and I'm giving it a content type patch.json. And in this JSON, I'm doing exactly what I just showed you, but now I am concatenating /etc/patchwd. So I get basically the information that is there in my patchwd file. I can also do any other command, but just to show you something. Fun part is I just executed on this item/1, which was there as a get endpoint, purely to get my first item out of my grocery list. Interesting. So by doing this, let me just do this. I want you now see that this is actually what is there in my patchwd file. Just check your own patchwd file, and it looks like something like this. But if I can see my patchwd file, I can see other files, and I can probably, because I'm running this as root, unfortunately, I can do a bunch of other commands. And this is not something that is there because of the business logic that you created or that the people created using this. This is because you were using a wrong snapshot version, in this case, of an outdated Spring Boot. Got me? So think about it next time when you get your dependency in is, hey, did I pick the right dependency? Did I pick it for a right reason? And more importantly, aren't there any security issues at that point in time? But not only at that point in time, make sure that you reevaluate this on a regular basis by, for instance, scanning. And you can automate these kind of things. But because if you're using it, it's in production and it's there already, and something new is found and somebody published it, but you didn't update your Spring Boot version forever, then you might be vulnerable. So think about these dependencies just as much as you think about your own custom code. Cool. I can close this one. I can make sure that this one is not running anymore because we go back to the other application. But first, input. Well, we always know that users need to get input, but we can also get input from other systems. But what we should be careful with input. Basically, every input that you get from a source should be considered as malicious. If that is your way of thinking, then you're doing it right away. Because for what can happen, for instance, is so-called cross-site scripting. And cross-site scripting literally means that I'm trying to insert a script that will be executed on somebody else's machine. I try to insert some logic, and hopefully the next user, for instance, who gets on that page will get attacked by that. And rule 0 for preventing cross-site scripting: never insert untrusted data except in allowed locations. So we have to be sure that if it's untrusted, and that means basically every user that uses your system should be considered as untrusted, because you don't know who he is, who she is, or if he or she is actually who he says he or she is. Got me? Even authentication is not a particular thing. Even if somebody is authenticated, he or she might be doing wrong things. So we should be careful with that, and we should be only allowing these things in the places where they need it to be. For every other thing, we need to make sure that the stuff is sanitized. And sanitization is not hard, but we need to think of that. Luckily, there are a lot of helpful frameworks that can help you. And I'm doing that again, and I don't need to do that again. I never learn. But let me get back to that application I showed you before, like this application. I need to restart it, I know, because the demo application was not running anymore. But the point with sanitization is a lot of people forget to sanitize stuff. Yes, please run, help me. I should be doing this with less heavy stuff. So let's go back to the search. I'm here. So what I can do over here, I can add a new user, and I can give it a username, and I say hello. That's my username, and my first name is Brian. My last name is Vermeer. My last name is 123456, because that's the most secret password you can have. Of course, you need to blank this out. But again, what I can do over here, I can, for instance, in the comment, I am trying to do things like this, because I know there's no sanitization in there. And hey, everything that is there will get straight to the database, and from the database straight to my output. So if I submit this, it will be submitted. It's okay, hello is added. And if I go back to the search thing, you will see that boop, I have an alert message. So JavaScript can be executed because I didn't sanitize it as much and at the back end. I am using Timeleaf over here. So you can sanitize it in Timeleaf already, but you should, if you even use a separate front end and separate back end, don't trust only on front end things, because even though you can sanitize it on the front end, it might be, people might be able to call again REST endpoints directly. So you should sanitize it on the back end. And for instance, you can sanitize it by using certain libraries. An example of such a library is the OWASP library for encoding. And I like this one because it has a lot of encoding in place, and I will search it up for you. Here, this one it is. So what you see over here is I have the OWASP encoder, and the OWASP encoder can encode and therefore escape certain characters for me for certain specific outputs. So what I can do over here in my user controller, I am saying add user. This is the get, this is the post mapping, add user. And let me do this now for the sake of demo in a nasty way. Just say it what it is, a nasty way. Because normally you should be having a layer in between, like not just getting an object or domain entity in and save it, but having transfer objects. That will be the better choice to do. But let me just fix this right away, like quick and dirty, like we do everything. I can say user repo dot, well, it has getters and setters because, or it's not the user, it's say user dot set comment. So I will override the comment with, and just to show you that I can use in encoder, I think it was encode dot for HTML, for instance, and I will do the user get comment. Yes, I know this is not the way how it's used, but I just want to demo that encode for HTML can help me with sanitizing specifically for HTML. So I know that when the output in this case is HTML, it will not be harmful. By doing this and restarting my thing again, we will find out that the JavaScript is not JavaScript anymore, but is escaped by, I guess it's URL encoding. So it will show the actual tag of script, alert one, etc. But again, this is not the way how you should be using it, but this is just to demonstrate that you could use simple encoders that are there available freely for you to do these kind of things. And if I do this again, I add a new user, and let me just put some bogus stuff in. And I say here again, the alert, what I did before. When I submit it, you will already see that, you see there is URL encoding over here. So if I go to the search one, I see it's not pretty, but hey, I now find out that somebody tried to do SQL or to do a cross-site scripting. Hopefully I logged enough to see who it was, so I can actually go after it. Got me? But sanitization is an important thing, and this is also this is a very minimal thing. But everything that comes into your application is something that we have to take care of, even if it comes from another machine. Because if another machine is compromised, then it will have a chain of problems, if you get what I'm meaning, a domino effect. So for instance, you might consider sanitizing the stuff that comes from a database if that database is also accessible by other applications. And then we can argue if that should be the case or not, but hey, you got me. All right, oh, XML parses, I love this one. What we're going to show you is XML external entity injection. I've got a few minutes left and I've got a few things left. So let's get this one, because this one I like a lot. And I will again demonstrate this to you with this application. Because for instance, I can import stuff and I can import XML files to get new users in. But what if my XML file, looks like a normal XML file, it would look something like this. Like, you see, first name, last name, password, comment, etc. Right? Perfectly fine. This makes sense. So if I choose a file over here and I will do users.xml, I will open it, you will just see it works. Perfectly fine, it works. But what if my XML looks like user bat? Looks like this. And you see what I'm doing here? This one is not a comment. This one is a reference. It's a reference to an external entity. And reference is here created in a doc type. And this doc type refers to, again, my etc/-wd file, a file on my local system, which I know I have access to, or well, I hope I have access to that. So by inserting this, what I'm trying to do is get the content of the past.wd file and chop it into the comment section. Let's see if that works. And of course that works, because that's why I created it. However, we should be aware that this is just default behavior. I'm just using a plain old, let me just do it first. So you see that now in my comment is the content of my past.wd file, and that is not particularly what we want. What happens is I'm using a sex parser over here, SAX. This is the implementation. It's a very naive parser. It doesn't do a lot of things, but it just cycles through the thing. And we have different parsers already available in the JVM or in the JDK, and all of them are vulnerable for this, because by default external entities are on and doc type definitions are on because of DTDs. But it's not what we want. So by doing this, I'm vulnerable. What I can do, and I made a little cheat sheet over here. I can say, for instance, I can disallow doc types, but that's not what we want. Sometimes I might even, or I can disallow external entities. That's maybe something I'd rather use more. So what I do now, for instance, on the factory, I have to actually set that external entities are not welcome. I don't want external entities, because by default this is on. Remember that. Using an XML parser by default is vulnerable for XXE. By doing this and doing that again, you will see it will just ignore the external entity and continues. And there are a lot of things you can do about that. You can disallow doc types altogether. That's in this case not what I want, because hey, maybe I need doc types for some other reason. But if I import the same thing now and I do that user bat and I submit this, you will see that the comment section over here is empty because I'm not allowed to get into external entities. So again, doesn't matter. I'm using one flavor of a parser. It can be another flavor as well. Pay good attention if you use something, what kind of settings there are and what settings are by default on and off. By default, for every Java parser in XML parser, this is allowed. The big elephant in the room, Java serialization. Also known to the gift that keeps on giving, because so many security issues came out of Java serialization. For those who are not familiar with serialization, a very quick recap in 30 seconds. Say you have an object. An object is there, lives in your application, and we want to store it, or you want to send it over the line. We need to serialize this to a byte stream. And a byte stream can also be, on the other hand, can be strings and can be, say, JSON is basically also serialization from an object. But let's keep it to Java serialization. Object, transform it to a byte stream so we can store it either on a disk or send it over the line to another system. Of course, deserialization is literally the other way around. So we have a set of bytes, so we have a byte stream from storage that we have in a file or from the network, and we transform that back into an object. All good. Now we have a code example over here. So we have an object, and an object implements serializable, and it has two strings, value and side effect. Okay. Well, I've got my second constructor. That's the important one. This one says that this value is value, and side effect is actually something that is set on creation. It's basically a timestamp. Got me? So the timestamp is not something that is set from the beginning using the constructor. And what we do here is, this is the code below. This is the basic way how to serialize this object and how to put it into a file. And it goes into value object.ser. Got me? I will publish the slides, so don't worry. if I look at that value object and I look at it with a hex editor, it looks something like this. Hey, it's in my system. You see on the right-hand side where what the characters mean. You see that there is a time over there. There's a timestamp, and it has that string, that's value that's set high. But what I can do with an hex editor, I can change it. So I can easily change it to this. Just changing it, the last few sequences from 002 to whatever it is to 005 something, and it says hello. So already it's not encrypted or something like that. So serialized objects, if you can intercept them, you can change them. And more importantly, we are not using, by deserialization, you typically do with this piece of code. So I get that value object, oh, it says value object 2, but value object, doesn't matter. And we get an object stream out of that, and we read the object. But what happens there? Serialization in Java doesn't respect the constructor. It doesn't use the constructor, it uses a lot of reflection. So with reflection, it inserts the fields into the object that are there. That means that, for instance, the timestamp that was normally created with the constructor is just inserted. It just bypasses the whole constructor phase. Then again, we call on the object, we call the function, we call the method read object. And read object is already called, and it's already in memory before the casting is there. And that is important, because if read object has side effects, things might go wrong even before it's casted, because you will get a cast exception, but the harm is already done. So say we have a serializable object and I implement that read object thing. And what I do over here is one of my fields here is a runnable command. And in that read object, you see that is the one that is called reflectively by deserialization. You see that I do the default read, and then I actually run the command. So I have a side effect. And this is what we call a gadget. So basically by deserializing it, it does something, not just plain text or mapping object fields to the actual object, but actually doing something. If we have this, we call this a gadget. And if we have a gadget and it's an entry point in our system, we can connect a bunch of objects together and make a chain of that. Like, hey, if something calls something else, you get that? We call that an attack chain. And an attack chain can be harmful. And an attack chain, so such an attack chain is quite hard to create. However, there are a lot of classes available in your system because of the dependencies that you have in. And probably a bunch of them are serializable. And some of them might even have a side effect, might be gadgets like this, like do something else in the read objects. Just to show you an example, let's go, for instance, to let's go to classes hashset. Hashset is an interesting one. If we go to hashset and we look like read, oh, this is object input stream. Where's my hashset again? Here, read object in hashset. So it does not in, and that's just in a JDK. So basically we can already say, because it does a bunch of logic, that hashset and hashmap are already gadgets itself. And if you combine it with all the classes we have in your class path, you might be vulnerable to a chain of attack with deserialization. I can go on and on deserialization. I can spend an hour on that. But what can we do? But what if I need to implement, for instance, serializable because my domain demands me to? Well, you can import that private final read object and give it an exception. So the serialization for that object is not possible anymore. But we need to prevent deserialization and serialization altogether as much as possible. So one thing we can do as well, if we do need to depend on serialization, maybe we get into things like Apache Commons IO. Apache Commons IO has the validating object input stream. So instead of a normal input stream, an object input stream, now you're able to inspect that input stream before you call that read object. And with that validating input stream, I can create a allow list like value object.class. That's the one I want to deserialize. And if it's not that thing, it will just stop over there. So if you depend on serializable, just use this one. So you're at least a bit safer, but try to avoid serialization altogether. Let me get into the last one, encryption and hashing. First of all, don't write your own encryption unless you are a cryptographer. If you know a lot about encryption, go ahead. But I'm not sure that we are good at it. I'm a software developer. I'm not into mathematics, low-level encryption part. So we can use the Java low-level encryption capabilities, but that's also quite difficult how to do that. Luckily, there are strong vetted, strong used, and well-used libraries. Well, we have basically two ways of encrypting. The normal two-way encryption, like I have a credit card, I make an encryption hash thingy out of this, and I need to get back to the original. Got me. For a credit card, that makes sense, right? And we also have the one-way encryption thing. Well, one-way, let's call it hashing. Hashing is the right word for that. And hashing needs to be deterministic. So if I have a password, it needs to create the same hash. If I do that same password again, it needs to create the same hash. If I do another password, it needs to create another hash. But we cannot go back from the hash to the password. Got me? Well, there are libraries available that I already said. For instance, for encryption, use the Advanced Encryption Standard, AES, from, for instance, Google CryptoThink. And Google CryptoThink is a well-known library that can use this for you, and it looks something like this. Basically, what I'm trying to do, I'm trying to encrypt a string, a plain text, with associated data. If you want to know more, you have to look it up because we do not have time. But I basically can say, because we go with byte streams, I can encrypt the plain text stuff and I can decrypt the plain text stuff. And I need to use a base 64 encoder and decoder to do that. Not that hard as getting into the low-level capabilities of encryption. So this is something you should look into. Google Think, so without the H. For password encryption, if you want to do password encryption yourself, go to Spring. Spring has perfect hashing capabilities, and this is an old one, 5.2.2 release, but you get me. Get the latest one. And with Spring Security Crypto, that is the package that holds these cryptography, these hashing algorithms. And what I can do here is I can use, for instance, the bcrypt password encoder, and I can encode a raw password. And if I have that hash, and it automatically has salting. Salting is there that if two different users have the same password, it will not end up in exactly the same hash, but it has something extra in it. And it automatically salted and desalted this. So you need to use the same encoder to match the plain text password with the hash. But if you do this, you are way more safer than creating it yourself. And currently, bcrypt, scrypt, and I'm not sure what the third one is, are the three most commonly used and most well-used, most capable encoders or hashing algorithms by OWASP. So bcrypt and scrypt are there in Spring, and they are there free to use it. We have a minute, right? Because the last one is not so much about security, but it's about logging. Because if something goes wrong, you will probably face a bunch of questions. These. If you have a data leak, the first thing is your manager comes up to you and says, who was exposed and how long was it in and what is the impact? And we can only say that if we have proper logging available. If you don't log the stuff that you're there, that happens, it's just black for you. You cannot understand what's happening anymore, and you have to assume that everybody is exposed. That's not what you want. So first of all, log everything. Log everything that is there, and next to that, try to do that centralized. Try to make it centralized, and there are a lot of things like there, and I will not make any advertisement to who has that. But if you centralize that logging and it's easy accessible, then you can do active monitoring on it and active alerting. For instance, hey, actively alerting on high CPU is something that you want, not only for security, but probably it can be that somebody is DDoSing you. But also things like a lot of 500 errors for a different server, or somebody tries to reset an admin password, or SSA connection to a server that normally doesn't happen. You get me? Or IP regions that are connected from outside while they're only for inside use. If you can describe that and put automation in that and active logging and active alerting on that, you are preventing and you're helping yourself, people might be in but couldn't do as much damage yet. So centralized logging, so you can do a really good postmortem and fix the stuff, but active alerting to prevent more harmful stuff while people are in, and you can shut it down, because hey, not available is a problem, but it's better than to be not available than to get all the data of your customers out, right? If you want to know more, we created a 10 Java security best practice cheat sheet. That's I created it together with Domenico some time ago, like about a year ago, and it's there on the Sneak website. You can just Google for Java security best practices or Java security cheat sheet and Sneak, and you probably will find it. All right, I'm already 5 minutes over time. I want to thank you for listening to my rambling, and I hope you thought it was good, or at least it was useful. If you have any questions, feel free to ping me on Twitter or ask it now if you have time. I'm here.
Thank you, Brian.
All right.
Let's check. There is no question at the moment.
Well, if somebody wants, yeah, sorry.
I'm sending via chat.
Feel free to ask questions later, for instance, by pinging me on Twitter. That is the easiest way. If you come up with a question, say tomorrow, ask it to me on Twitter. That is the best and quickest way, and I will do my utmost best to answer it. I will publish the slides for anyone who cares, and I hope you enjoyed it. So thank you.
I think there is one question. Can you see the questions, or I can forward it to you?
I cannot see the question, unfortunately. Let me just check over here.
Okay, I just sent it from your chat. I just forwarded.
One of the questions is, by using escape, did you remove bad characters?
If you mean the encoding, I'm not removing. I'm transposing. So what you saw, what happens is the less than sign and the bigger than sign were automatically transposed into HTML encoding for this, and I can use the encoding that I want, that is applicable for my situation. In this case, it was HTML, but in some cases it might be different. So that library, that OWASP library, has like a ton of encoders available for you to play with and to use when you do sanitization.
Okay, the other question: what was the major worst security incident that you have ever encountered?
That is a really, really good question. I cannot name any names, unfortunately, well, because non-disclosure argument, but I told you about getting too much information out. That actually happened to me. That what we did was we had an endpoint, and for some reason it displayed an ID together with another ID from another endpoint that was also displayed in the raw JSON, not so much in the mobile app where we're creating the backend for, but connecting these two IDs with some other information could land you into the physical address of a particular person. So at that point, you could connect email addresses to physical addresses. That means in your email address, normally there's your first name, last name, and your company name, for instance, and your physical address is where you live. Well, if you connect that together, by law here in the Netherlands, at least at that point, it's a data leak. And if you do that for a big company, we were still in beta, so it was not a lot of users. You have to make that public, and you have to say we made a mistake. The fix was 5 minutes. We found out, we did the JSON ignore what I showed you, and it was all fixed. However, we didn't have enough logging in place, so we couldn't see how many people were actually exposed. So most of these examples were actually things that I encountered myself, like the logging and like the exposing too much information in a REST endpoint. Trust me, it took us 5 months of paperwork and coping with management, who was like, take care of that. They had no knowledge of that, but you are on a magnifying glass. They were now looking at you at every move that you make, which is not funny anymore because you want to build stuff. I hope that answers the question.
Okay, there is one more question. Would active security scanning be better involved in the first stage of development, or should it be done as a side task in the end of delivery chain?
I would say in every step. So if I import a library, let's scan it right away. Let's scan it when I import. Let's scan it right away if there are known vulnerabilities. If they're not, I can use it, right? The point is, if there are vulnerabilities, I probably want to use or another package or another version, and that might change API. So I want to scan already as soon as possible, but you need to scan through the life cycle. So that means before I go in production, I still want to have my scan that things are okay, both in your code, but also in your dependencies. But for instance, for your dependencies, because that's not code that you control, you also need to scan while you are in production. With our tooling, for instance, we can do that by taking a snapshot and we scan that on a daily basis. You can try it out for free at sneak.io. No commercial thing, you do not have to pay, it's free. But the point is, you need to scan it over there as well, because it might be okay now, but if somebody found out that with that weird header that I showed you, you could break in, that is found over time. So that means it can be 2 weeks from now or 2 months from now. And if it's still in production and I don't pay it any attention anymore, so you need to do it both on your local machine all the way to in production and over again. So it means that constantly scanning that. And you can do that on your local machine in your IDE. We have stuff for that. You can do that in your you connect your Git repository to that. You can connect your CI system to that, and you can create a snapshot before you go in production so you know what's happening. So you need to have relevant information, on-time information, and automatically scan that and ping you back with, hey, there's something wrong and we have a solution for you. That would be the most perfect way to do it, in my opinion.
Okay. One more question. Do you want to reply or?
All right. Well, then I want to thank you all for listening, and I hope you enjoy the rest of the days of Java. We have to say plural, right? It's now Java Days Istanbul,
Yeah.
because it's multiple days. And hopefully next year back again, real life in Istanbul. I'm looking forward to that.
Yes, me too. Thank
All
you
right.
so much.
Thank you so much, and enjoy the rest of your time. Bye-bye.
Bye.